To assess competitiveness in electrical estimating, consider factors such as location, size, condition, and level of detail. Location can influence labor costs, material availability, and competition. The square footage, number of rooms, and condition of the house affect the scope of work and materials required. The level of detail included in an estimate, such as specific materials or fixtures, can impact the price. An estimate of $11,000 may be in the ballpark. A house size with 4 bedrooms, 3 bathrooms, and 2 floors, and amenities such as a fully appliance kitchen, central air, and partially finished basement are comparable to other homes of similar size in the area. The price includes most typical electrical work, such as telephone and cable. The homeowner is responsible for light fixtures, which reduces material costs. Regarding potential areas for savings, if the scope of downlighting is limited, it could be an area to save some money. The estimate does not include any specific upgrades or special features, so there may be potential to reduce the price further if those are not required. Potential areas for increase may include the 200 amp underground electrical service, which is a significant upgrade, which could add to the cost. If the homeowner requests any additional features such as smart home technology or security systems, the price would likely increase. Labor costs can vary depending on the availability of electricians in your area. When estimating electrical work, firstly, analyze the scope of work, which involves carefully reviewing the project specifications, blueprints, and any other relevant documents to understand the full extent of the electrical work required. This includes identifying the number and type of electrical outlets, lighting fixtures, appliances, and other electrical components that need to be installed or upgraded. Secondly, determine the materials needed and make a comprehensive list of all the materials required for the project. This may include wiring, conduits, electrical boxes, switches, outlets, lighting fixtures, circuit breakers, panels, and other hardware. Obtain pricing information from suppliers or wholesalers to estimate the cost of each item. Thirdly, estimate the labor hours and break down the project into smaller tasks and estimate the number of labor hours required to complete each task. Consider factors such as the complexity of the work, the skill level of the electricians, and any potential challenges or obstacles that may arise. Multiply the estimated labor hours by the hourly rate of the electricians to determine the labor cost. Fourthly, factor in overhead and profit, and allocate a percentage of the total cost to cover overhead expenses such as insurance, permits, equipment rental, and administrative costs. Add a profit margin to ensure that the estimate is financially viable for the business. Fifthly, consider any additional costs, which include any additional costs that may be associated with the project, such as travel expenses, accommodation, or specialized equipment rental. These costs should be factored into the estimate to ensure accuracy. Sixthly, review and finalize the estimate, and carefully review the estimate to ensure that all costs are accounted for and that the pricing is competitive. Make any necessary adjustments based on market conditions, competition, or specific project requirements. Prepare a formal proposal or quote to present to the client. When assessing competitiveness of an electrical estimate, several factors need consideration. These include direct costs, which are the expenses directly tied to the project, like materials and labor. Indirect costs, which cover overhead, such as insurance, rent, and utilities. Market rates, which are the prevailing prices for similar electrical work in your area. Profit margin, which is the percentage added to cover business profits. Risk assessment, which accounts for potential unforeseen issues or delays. Competitive analysis, which compares your estimate with others to ensure your pricing aligns with the market. Value proposition, which is what you offer in terms of quality, service, and expertise that justifies the price. Customer relationship, and how your interaction with the customer influences their perception of the value. Project scope, the detailed requirements of the job influence costs. Payment terms, and how payment is structured. Overall, an estimate of $11,000 seems reasonable based on the information provided. However, it is important to consider the factors mentioned above and consult with other electricians in your area to ensure pricing is competitive. Some additional factors to consider are firstly the complexity of the wiring, which will depend on the age of the house. Older homes may have outdated wiring systems that need to be replaced, which can add to the cost. Secondly, the location of the house will play a role. Houses located in urban areas tend to be more expensive to work on than those in rural areas. Thirdly, the time of year can be a factor. Electrical work is often more expensive during the summer months when demand is high. Fourthly, the type of electrician you hire will affect the price. Licensed and insured electricians typically charge more than unlicensed electricians. Fifthly, the specific services are important to understand. Make sure you get a detailed breakdown of the services included in the estimate. This will help you compare prices from different electricians. Some ways to save money on electrical work are firstly, get multiple estimates, which allows comparison shopping. Secondly, consider doing some of the work yourself, such as removing old fixtures. Thirdly, be flexible with your scheduling, as electricians may offer discounts for work done during off-peak hours. Fourthly, ask about discounts and see if the electrician offers any discounts for seniors, veterans, or other groups. Fifthly, negotiate the price, and do not be afraid to negotiate the price with the electrician. Some tips for evaluating an electrical estimate are firstly, check the electrician's qualifications, such as their license and insurance. Secondly, read the fine print, which includes understanding the terms and conditions of the estimate. Thirdly, ask questions, and do not hesitate to ask the electrician any questions you have about the estimate. Fourthly, get a written estimate, which will help you avoid any surprises down the road. Fifthly, compare estimates, and make sure you are comparing apples to apples. Another factor that is important to consider is the National Electrical Code, or NEC. The NEC is a set of standards for electrical wiring and equipment in the United States. It is important to make sure that all electrical work is done in accordance with the NEC. Some of the most common NEC violations are firstly, using the wrong size wire. The NEC specifies the correct wire size for different electrical circuits. Using the wrong size wire can create a fire hazard. Secondly, not grounding electrical outlets. Grounding electrical outlets helps to protect people from electric shock. Thirdly, overloading electrical circuits, which can also create a fire hazard. Fourthly, using damaged electrical cords, which can cause electric shock or fire. Fifthly, not using GFCI outlets in wet locations. GFCI outlets are designed to protect people from electric shock in wet locations such as bathrooms and kitchens. To find a qualified electrician, firstly, ask for referrals from friends, family, or neighbors. Secondly, check with the Better Business Bureau. Thirdly, verify the electrician's license and insurance, and that they are properly licensed and insured. Fourthly, get multiple estimates, which allows you to compare prices and services. Fifthly, read online reviews, as they provide insights into the electrician's reputation and quality of work. When comparing electrical estimates, firstly, ensure that all estimates include the same scope of work. Secondly, compare the prices of individual items such as wiring, outlets, and fixtures. Thirdly, factor in the electrician's qualifications and experience. Fourthly, consider the electrician's warranty, if they offer one. Fifthly, read the fine print carefully and understand the terms and conditions of the estimate. By considering these factors, one can make an informed decision about hiring an electrician and ensure that the electrical work is done safely and correctly. Regarding the 200 amp service, the load calculation is crucial for determining the appropriate size of the electrical service for a home. This calculation ensures that the service can safely handle the expected electrical load of the house. It involves several steps, which are firstly, calculating the general lighting load. For general lighting, the NEC specifies a minimum load of 3 volt amps per square foot. Calculate the square footage of the house, excluding unfinished basements, garages, and attics. Multiply the square footage by 3 volt amps per square foot to determine the general lighting load. Secondly, determining the small appliance and laundry circuits. The NEC requires at least two 20-amp small appliance circuits for the kitchen and one 20-amp laundry circuit. Each of these circuits is calculated at 1500 volt amps. Therefore, the total load for small appliance and laundry circuits is 3 times 1500 volt amps, which equals 4500 volt amps. Thirdly, accounting for appliance loads. List all major appliances, such as the electric stove, electric dryer, water heater, dishwasher, and garbage disposal. Use the nameplate ratings of these appliances to determine their volt-ampere loads. For the electric stove, if the nameplate rating is not available, you can use the NEC table 220.55, which allows for demand factors based on the number of cooking appliances. For the electric dryer, use 5000 volt amps for the nameplate rating, whichever is higher. Fourthly, calculating the heating and air conditioning loads. For all hot air heat with central air, the larger of the heating or cooling load should be used. Determine the volt-ampere rating of the air conditioning unit from its nameplate. For the heating system, if it is electric resistance heating, use the nameplate rating. If it is an oil-fired system, the electrical load is usually minimal and can be included with other small loads. Fifthly, accounting for other loads. Include any other significant electrical loads, such as electric vehicle chargers, hot tubs, or large power tools. Use the nameplate ratings to determine their volt-ampere loads. Sixthly, applying demand factors, and applying demand factors as permitted by the NEC to reduce the calculated load. Demand factors account for the fact that not all electrical loads will be operating at the same time. For example, NEC table 220.42 allows a demand factor of 75% for the portion of the general lighting load exceeding 3 volt amps per square foot for dwellings. NEC table 220.53 allows demand factors for ranges, dryers, and other appliances. Seventhly, summing the loads. Add all the calculated loads, including the general lighting load, small appliance and laundry circuits, appliance loads, heating and air conditioning loads, and other loads, after applying any applicable demand factors. This will give you the total calculated load in volt amps. Eighthly, calculating the service amperage. Divide the total calculated load in volt amps by the voltage of the service, which is typically 240 volts for a residential service. This will give you the required service amperage. For example, if the total calculated load is 30,000 volt amps, then the required service amperage is 30,000 volt amps divided by 240 volts, which equals 125 amps. Ninthly, selecting the service size. Select a service size that is equal to or greater than the calculated service amperage. In this case, a 200 amp service would be adequate as it provides ample capacity for the calculated load. However, it's always a good idea to provide some extra capacity for future expansion. Tenthly, checking the panel board capacity. Ensure that the panel board has sufficient capacity to accommodate all the branch circuits required for the various electrical loads. The panel board should have enough available spaces for circuit breakers to serve all the lighting, receptacles, appliances, and other equipment. To perform an accurate load calculation, firstly, gather all the necessary information, which includes the square footage of the house, appliance nameplate ratings, and heating and cooling equipment specifications. Secondly, follow the steps outlined above to calculate the total load. Thirdly, consult with a qualified electrician or electrical engineer to review the load calculation and ensure that it meets the requirements of the NEC and local codes. Some common mistakes to avoid when performing a load calculation are firstly, underestimating the electrical load, which can result in an undersized service that cannot handle the demands of the house. Secondly, failing to account for future expansion, which can limit the homeowner's ability to add new electrical loads in the future. Thirdly, not applying demand factors correctly, which can result in an oversized service that is more expensive than necessary. Fourthly, overlooking important loads, such as electric vehicle chargers or hot tubs, which can lead to an inaccurate load calculation. To perform a load calculation, start by determining the square footage of the home. For a 2-story, 4-bedroom colonial, estimate the square footage of each floor and add them together. For example, if each floor is 1,500 square feet, the total square footage is 3,000 square feet. Next, calculate the general lighting load. The NEC specifies 3 volt amps per square foot for general lighting in dwelling units. Multiply the square footage by 3 volt amps per square foot to get the general lighting load. In this case, 3,000 square feet times 3 volt amps per square foot equals 9,000 volt amps. Then, add the small appliance and laundry circuit loads. The NEC requires at least 2 20 amp small appliance circuits for the kitchen and 1 20 amp laundry circuit. Each 20 amp circuit is calculated at 1500 volt amps. The total load for these circuits is 3 times 1500 volt amps, which equals 4500 volt amps. Next, calculate the appliance loads and list all major appliances and their nameplate ratings. For the electric stove, use the NEC table 220.55 if the nameplate rating is not available. For example, if the stove is rated at 10 kilowatts, that is 10,000 volt amps. For the electric dryer, use 5,000 volt amps or the nameplate rating, whichever is higher. Then calculate the heating and air conditioning loads. For the central air conditioning, use the nameplate rating. For the oil hot air heat, the electrical load is usually minimal and can be included with other small loads. Next, determine any other loads. Include any other significant electrical loads, such as a partially finished basement. Then apply the demand factors. For the general lighting load, a demand factor of 75% can be applied to the portion exceeding 3 volt amps per square foot. For appliances, refer to NEC table 220.53 for applicable demand factors. Next, sum the loads, and add all the calculated loads after applying the demand factors. This will give you the total calculated load in volt amps. Divide the total calculated load by the voltage of the service, which is typically 240 volts, to get the required service amperage. In this case, if the total calculated load is 30,000 volt amps, then the required service amperage is 30,000 volt amps divided by 240 volts, which equals 125 amps. Select a service size that is equal to or greater than the calculated service amperage. A 200 amp service would be adequate for this scenario. Finally, check the panel board capacity to ensure that the panel board has sufficient capacity to accommodate all the branch circuits required for the various electrical loads. Another factor to consider is the cost of materials, which can vary depending on the type and quality of materials used. Some materials, such as copper wiring, are more expensive than others, such as aluminum wiring. The cost of materials can also vary depending on the supplier. To get the best prices on materials, it is important to shop around and compare prices from different suppliers. Labor costs can also vary depending on the electrician's experience, skill, and location. Electricians with more experience and skill typically charge more per hour than less experienced electricians. Labor costs can also vary depending on the time of year and the demand for electricians in your area. To get the best prices on labor, it is important to get multiple bids from different electricians. To minimize costs, firstly, use energy-efficient lighting fixtures and appliances, which can save money on electricity bills. Secondly, properly insulate the home to reduce energy consumption and lower heating and cooling costs. Thirdly, install a programmable thermostat to automatically adjust the temperature when one is away or asleep. Fourthly, seal any air leaks around windows, doors, and other openings to prevent drafts and reduce energy loss. Fifthly, consider using renewable energy sources such as solar panels or wind turbines to generate electricity and reduce reliance on the grid. Some common electrical problems that homeowners may encounter include flickering lights, which can be caused by loose wiring, faulty fixtures, or voltage fluctuations. Frequent blown fuses or tripped circuit breakers, which can indicate overloaded circuits or faulty wiring. Outlets or switches that do not work can be caused by loose wiring, damaged components, or tripped GFCI outlets. Electric shocks or sparks when using electrical appliances, which can be a sign of serious electrical problems that require immediate attention. Overheating outlets or switches, which can be a fire hazard and should be addressed immediately. To troubleshoot electrical problems, firstly, ensure safety first by turning off the power to the affected circuit or appliance. Secondly, inspect the wiring and connections for any loose or damaged wires. Thirdly, test the outlets and switches with a multimeter to check for voltage and continuity. Fourthly, reset trip circuit breakers or replace blown fuses with the correct amperage. Fifthly, consult a qualified electrician for any complex or potentially dangerous electrical problems. Regular electrical maintenance can help prevent problems and ensure that electrical systems are operating safely and efficiently. Some tips for regular electrical maintenance include inspecting wiring and connections regularly for any signs of damage or wear. Testing GFCI outlets monthly to ensure they are working properly. Replacing any damaged or frayed electrical cords. Keeping electrical panels and outlets clean and free from dust and debris. Having a qualified electrician inspect the electrical system annually to identify and address any potential problems. Remember that electrical work can be dangerous, and it is always best to consult a qualified electrician for any complex or potentially dangerous electrical problems.